discussed the problem last time. Sin square x equals to 1 by 4, where 0 is less than or equal to x less than or equal to 2 pi. So, we found 4 values between 0 and 2 pi where it satisfies the equation sin square x equals to 1 by 4. This was a limited interval. At the same time, if we have sin square x equals to 1 by 4 and we need to find out x. So, if it is an interval, entire interval, there are infinite values of x which satisfy this equation sin square x equal to 1 by 4. So, we now proceed to find a general formula by which we can find out different angles, we can find out infinite angles which satisfy this equation. Here if the interval was limited between 0 and 2 pi, now we have values which are infinite and satisfy this equation. To proceed with, we have the formula here. This is termed as a trigonometric equations. For this, if sin of x is 0, then x equals to n pi, where n belongs to the set of integers. If we are in the know of this, that integers stand for 0, plus minus 1, plus minus 2, plus minus 3 and so on. If we substitute the values of n here, we get x equals to 0 itself, plus or minus pi, plus or minus 2 pi and so on. So, these are the infinite angles whose sine is 0. So, x equal to n pi we call the general formula for finding sin x equals to 0. Second formula in this is the basic formulas. If cos of x is 0, then x equals to 2n plus 1 into pi by 2. That means, if we put the values will be x equals to, for 0 this is pi by 2, and if we put plus 1 this is 3 pi by 2. If it is minus 1, it is minus pi by 2. If we put 2, this is 5 pi by 2. If we put n equal to minus 2, it will be minus 3 pi by 2 and so on. If you take this is 1 into pi by 2, 3 into pi by 2, 5 into pi by 2. So, these are odd multiples of pi by 2, and if you take the minus 1 minus is an odd multiple of this. So, to say cosine of all these angles is 0, and we know it orally that cos of pi by 2 is 0, cos of 3 pi by 2 0, and so on. Cos of minus pi by 2 is 0. We can find the values of these angles by making use of allied angles, which we have already discussed under the chapter allied angles. Then comes third is, if sin x equals to say sin of alpha. So, for instance, we have sin x equal to say 1 by 2, where sin of alpha is 1 by 2, or you can take it otherwise also, that if sin x equal to say k and value of k lies between plus 1 and minus 1. So, k stands for where k is sin of alpha. So, to find the general formula in this case, then x equals to n pi plus minus 1 raised to power n into alpha, where of course n belongs to set of integers. Now, to develop this formula, we start with this. Here sin of x equal to sin of alpha, or by transposition we bring sin alpha to the left hand side. So, there is a difference of two signs. We shall try to change it into the product form, that is using the formula sin c minus sin d as 2 cos c plus d by 2 into sin c minus d by 2. We are familiar with this formula. So, this is twice cos of c plus d by 2 sin c minus d by 2 equal to 0, or we have cos of x plus alpha by 2 sin of x minus alpha by 2 equal to 0. Here dividing by 2. So, 0.2 here will give you 0. So, this is a product of two expressions. One is cos x plus alpha by 2, another is sin x minus alpha by 2. So, here we write either cos of x plus alpha by 2 equal to 0, or sin of x minus alpha by 2 equal to 0. If cosine of some angle is 0, we make use of the second result, that if cos of some angle say x is 0, then x equal to 2n plus 1 pi by 2, that is odd multiple of pi by 2. So, here instead if you compare, instead of x we have x plus alpha by 2 equals to 2n plus 1 into pi by 2. This 2 cancels with this. We have x equal to 2n plus 1 pi minus alpha. Now, this I can write down as x equal to 2n plus 1 is odd multiple formula here. Okay, if sine of some angle say x is 0, then x equal to n pi. So, we have here from this result that sine x minus alpha by 2 equals to n pi and x minus alpha equal to 2 n pi, and finally therefore x equal to 2 n pi plus alpha, and I can write down this as x equal to 2n is even number. So, even number multiplied by pi, that is even multiple of pi plus alpha, and mark it as number 2. So, this is first result, this is second result. Combining first and second, we have x equal to n pi plus minus 1 raised to power n into alpha. Well, if we get this n pi plus minus 1 raised to power n into alpha, here we are using the letter n belongs to set of integers. You can still modify it as, instead of 2n plus 1, you can write down 2p plus 1, where p belongs to set of integers. So, you can write this also 2p plus 1 to pi. Here you can take the letter as q pi, where q belongs to set of integers. This is 2q pi, this is 2q pi plus alpha, and when you combine first and second you can use the letter n. Now, to understand, generally the students get confused over as to what method we have applied to combine first and second. That I will explain in the footnote here, that when n is odd, this is n is odd, that is n equals to 2p plus 1, odd number. So, this is x equal to 2p plus 1, replace n by 2p plus 1 plus into pi plus minus 1 raised per n into alpha. So, this is your first result. Minus 1 raised to power n की जगह पे आप लिख सकते 2p plus 1 और x equal to 2p plus 1 into pi minus alpha. Basically, this is the first result. This is the first case. Next, let n is an even number. Even number. So, therefore, n equals to, that is n equal to 2q minus 1 raised to power even power is plus 1. Here we have made use that minus 1 raised to power odd power is minus 1. So, we have x equal to, in this formula replace n by 2q pi plus minus 1 raised per 2q into alpha, or x equal to 2q pi plus alpha, the second result. So, if you mark this as capital X, we note it that first result and second result are both present in X, this capital X. This is how we can establish that both these results, first and second, are contained in this result, x equal to this. Now, the practical utility of this formula I discussed in the initial stage, that if you n is an integer, if you substitute any integer, for example, integers are 0, 1, 2, 3, minus 1, minus 2, and so on. So, if you substitute the values here in this formula, x equal to, put n equal to 0, this is alpha, n equal to 1, we get pi minus alpha, put n equal to 2, so 2 pi plus alpha, and so on. So, where alpha would stand for the principal value, where alpha is numerically smallest value for which sin of alpha is k. This will further be explained in the actual numerical problems, and to understand this better, we shall take up The other example, if cos of x equal to cos of alpha, then x equal to 2n pi plus minus alpha. Of course, where n belongs to set of integers. So, from here we have cos of x minus cos of alpha equal to 0. By transposition we have taken cos alpha to the left hand side. Apply the formula cos of c minus cos of t, that is minus 2 sin of c plus d by 2 sin of c minus d by 2. We are converting the difference of cos x minus cos alpha into product by using this formula, x minus alpha by 2 equal to 0. Dividing both sides by minus 2, or we have sin of x plus alpha by 2 into sin of x minus alpha by 2 equal to 0. 0 upon minus 2 means 0. This is 0 on the right side. Either sin x plus alpha by 2 equal to 0, or sin of x minus alpha by 2 equal to 0. If sin of some angle is 0, we use the first formula discussed above. So, therefore, x plus alpha by 2 equals to n pi, or in this case x minus alpha by 2 is equal to n pi. Multiply crosswise here, or x plus alpha equal to 2 n pi. Therefore, x equal to 2 n pi minus alpha. This is first result. In the other case, we have x minus alpha is equal to 2 n pi, x equal to 2 n pi plus alpha. This is the second result. So, combining first and second, we have x equal to 2 n pi, 2 n pi, 2 n pi minus alpha and plus alpha, plus minus alpha, where n belongs to set of integers. Then the third result is next, if tan of x equal to tan of alpha, x equals to n pi plus alpha, where n is an integer. I can write down this as sin x from here, tan x is sin x upon cos x to sin alpha over cos alpha. If you multiply crosswise, So, we have sin x cos of alpha equal to cos of x sin of alpha. See, by cross we multiply, bring this cos alpha to this side, sin x cos alpha, and take cos x to this side, or sin of x cos of alpha minus cos of x sin of alpha equal to 0, or sin of x minus alpha equal to 0. If you remember the formula sin of a minus b, so this is sin of the first angle cos of the second angle minus cos of the first angle sin of the second angle. So, we make use of again this result, okay, if first result sin x equal to 0, then x equal to n pi. So, here x stands for this angle. So, x minus alpha equals to n pi and x equal to n pi plus alpha, of course, where n belongs to set of integers. Well, these are the basic formulas in trigonometric equations where we shall make use of this. Well, before we proceed further, we have another concept of principal value. Well, principal values. Given any equation, of course, trigonometric equation, given any trigonometric equations, for instance, sin of x equal to 1 by 2. The values of x which lie between 0 and 2 pi, that is 0 less than or equal to x equal to 2 pi. The values of x which lie between 0 and 2 pi are called the principal values. Principal values. So, here in this case, x equal to pi by 6 and 5 pi by 6. That is in first and second quadrant, where sin x is positive. Next, we shall discuss the general solution, where the principal value is required, that we shall discuss in the subsequent lecture, okay, how to find the principal values of a given trigonometric function. Now, for example, we have here, well, now we shall discuss some problems where we have to find out the principal values and the general solution. I am using the word general solution and principal as those separate terms. I write down here, find the principal values and general solution. Equation is first tan of x equal to root 3. Tan x is positive in first and third quadrant. So, the value of x or principal value of x in this case will lie in first and third quadrant. Of course, I have already explained you to find the values in the different quadrants. I again draw this x, x dash, y, y dash. Probably in my last two lectures, I made use of this figure and I called it as the horoscope. In first quadrant, the value is 0 to 90 degree. In second quadrant, it is 180 degree minus theta, and in third quadrant, it is 180 degree plus theta, and in fourth quadrant, it is 360 degree minus theta, where the theta is the value in the first quadrant. We observe here x equal to 60 degree, because tan of 60 degree is root 3. And then in third quadrant it is 240 degree, 180 plus 60, or x equal to, write down in radians, pi by 3 and 4 pi by 3. So, both these pi by 3, therefore, the principal values are pi by 3 and 4 pi by 3. And out of these two values, pi by 3 is a smaller value and this is a larger value, only two values in this case. For finding general solution, that means general solution here we mean we develop a formula from which we can find infinite angles which satisfy this given equation. So, out of these, for finding general solution, we use the formula here tan x equal to tan alpha, then x equal to n pi plus alpha. of course, where n belongs to set of integers. After having obtained the principal values in this case, we select the smaller of the two, that is pi by 3. So, we have tan of x equal to root 3, tan of x equal to tan of pi by 3. Now, if we compare this with this result, x, we have x here. If we have alpha, we have pi by 3. So, therefore, general solution will be x equal to n pi plus pi by 3, where n belongs to set of integers. Now, what is the utility of it? I discussed in brief earlier also that the utility of this result is that to satisfy this equation tan x equal to root 3, we have infinite angles, and those infinite angles are obtained by using this formula. N equal to integers, put x, so angle equal x equal to put n equal to 0. We have pi by 3 is one angle. Put n equal to 1, we have 4 pi by 3. This is 1 into pi, pi plus pi by 3. Put n equal to 2, 7 pi by 3. Put n equal to 3, 10 pi by 3, and so on. We can even put the negative integers also. For instance, we put n equal to minus 1. So, this is minus 2 pi by 3. Minus pi plus pi by 3 will give you minus 2 pi by 3. N equal to minus 2. Minus 2 will be minus 5 pi by 3. 10 equal to minus 3, minus 3, minus 3, minus 9 plus pi, minus 8 pi by 3, and so on. If you take tan of pi by 3, or you take tan of 4 pi by 3, or you take tan of 7 pi by 3 to dash so on, and value will be root 3. Likewise, if you take the negative angle, tan of minus 2 pi by 3, tan of minus 5 pi by 3, tan of minus 8 pi by 3, so on, the value is root 3. So, whether you take these angles as positive or negative, while making use of this general solution, we have obtained different angles, and the number of angles in this case will be infinite, both spread over the positive side and negative side. We can take up another example as secant x to 2. So, secant x is positive in first and fourth quadrant. So, making use of this chart, we can find out x equal to pi by 3, 60 degree, and then 360 minus 60 in the fourth quadrant, that is 300, 5 pi by 3. So, these are the principal values. For general solution, we use secant x equal to secant of alpha. We have the same formula as for cos. This is because cos of x equal to cos of alpha from this. So, we have the same formula, x equal to 2 n pi, this is 2 n pi plus minus alpha. So, therefore, general solution will be x equal to 2 n pi plus minus pi by 3, smaller of the principal values too. Next, where n belongs to set of integers. So, we can take up the other examples, as let us take an example where negative, the cosec of x equal to minus 2, negative in third and fourth quadrant. Okay. So, in third quadrant we have this value. Now, to find out the value in this case in the first quadrant, we for the time being keep our finger on the minus sign. If it were cosec x equal to 2, x would have been 30 degree or pi by 6. So, this will be equal to x equal to, in third quadrant it is pi 180 degree plus pi by 6, and in fourth quadrant this is 2 pi minus theta, that is value in the first quadrant, pi by 6. Otherwise, in degrees you can write down like this, x equal to 180 degree plus 30 degree and 360 minus 30 degree, or x equal to 210 degrees and 330 degrees, or we can write this x equal to 7 pi by 6, that is 210 degrees. So, by 6, the general solution is x equal to n pi plus minus 1 raised to power n into alpha. This is formula is sin of x equal to sin of alpha. For cosec x is equal to cosec alpha. So, formula will be x equal to n pi plus minus 1 raised per n to alpha. So, this will be n pi, that is 7 pi by 6, where n belongs to integers. Now, we next proceed to find the general solution of the trigonometric equations. For instance, we have first problem as cos 4x equal to cos 2x. Find the general solution. Well, solving such an equation, again we make use the same formulas which we have discussed above. Now this can be written as cos of 4x minus cos of 2x equal to 0. Apply the formula cos c minus cos of d. This is equals to minus 2 sin of c plus d by 2 sin of c minus d by 2. So, we have minus 2, c stands for 4x and d stands for 2x here. Minus 2 sin c plus d upon 2 and sin of c minus d upon 2 equal to 0. So, dividing both sides by minus 2. So, we have or sin of 4 plus 2 6 divided by 2 3x, sin of 4x minus 2x 2x upon 2 x to 0. So, either sin 3x is 0 or sin of x is 0. Either we have sin 3x equal to 0 or sin x is 0. We make use of this result, that sin of x equal to 0, then x equal to n pi. So, we have 3x equal to n pi, therefore, x equal to n pi by 3 or x equal to n pi. The net result will be, general solution will be solution is x equal to n pi by 3 and n pi. So, if we substitute n as an integer where n is an integer, whatsoever angle we get, all the angles will satisfy this equation cos 4x equal to cos of 2x, cos 3x. Second problem, cos of 3x plus cos of x minus cos of 2x to 0. Again we find general solution in this case. We observe here we have cos 2x here. If you combine the first two terms and simplify, we can take out cos of 2x because this is c plus d by 2. Apply the formula cos c plus cos of d, 2 cos c plus d by 2 cos of c minus d by 2. This formula we have already discussed. So, this will be twice cos of 3x plus x by 2 cos of 3x minus x by 2 minus cos of 2x equal to 0. So, this is cos twice cos of 2x cos of x minus cos of 2x equal to 0. So, well, or we take up cos of 2x common, there will be twice cos of x minus 1 equal to 0. Now, either cos of 2x equal to 0 or 2 cos x. So, this is 2x equal to 2n plus 1 into pi by 2 and x equal to 2n plus 1 pi by 4. One answer is this. If you take up this equation, we have cos of x equal to 1 by 2. Now, first we think of orally that cos x is positive in first and fourth quadrant. The principal value will be in the first quadrant pi by 3 and in the fourth quadrant it will be 2 pi by 3. I write down here principal value. As pi by 3 because cos pi by 3 is this. 3 pi minus 2 pi minus pi by 3 or pi by 3, this is 5 pi by 3. So, out of these two principal values we take up cos x equal to cos of pi by 3 and use the formula that cos of x cos of alpha then x equal to 2n pi plus minus alpha. So, this is in this case the second answer x equal to 2n pi plus minus pi by 3, where n belongs to set of integers. So, therefore, required general solution x equal to 2n plus 1 into pi by 4 and x equal to 2 n pi plus minus pi by 3. Of course, where n belongs to set of integers tan of 2x. Now, where we have this problem where secant square x and tan x are occurring, we convert this in terms of tan by using the formula, this is of class 10th, that 1 plus tan square A equal to secant square A. So, if it is secant square 2x, we will have 1 plus tan square 2x equal to 1 minus tan of 2x. One gets cancelled with this. So, we have tan square 2x minus tan of 2x to 0. Here it is 2x. Take out tan of 2x common. So, the tan of 2x minus 1 equal to 0. Either tan 2x equal to 0 or tan of 2x to 0. So, here we shall take sin 2x upon cos 2x 0. Sin 2x equal to 0, therefore, 2x equal to n pi. Therefore, x equal to n pi by 2. From this result, we have tan 2x equal to 1, tan of 2x after having found the principal value, this is pi tan of pi by 4. So, 2x equal to n pi plus pi by 4 or x equal to n pi by 2 plus pi by 8, where n belongs to integers. The formula here used here is tan x equal to tan alpha, then x equal to n pi plus alpha. Well, next we take up the problem 2 cos square x plus 3 sin x. Now, look here, for finding its general solution, if we visualize this equation, here we have cos square x and here we have sin x. Power of sin x is 1. It gives us a hint to convert this equation as quadratic in sin x, or this can be twice of 1 minus sin square x plus 3 times sin x equal to 0, or 2 minus 2 sin square x plus 3 sin x equal to 0. If we make this sin square x term positive, take this to right side. 2 sin square x minus 3 sin of x minus 2 equal to 0, and solve it a quadratic equation. So, sin x, use the formula x equal to minus b plus minus under root b square minus 4ac whole divided by 2a. So, this is sin x equal to minus b, that is 3 plus minus under root b square 9 minus 3 square plus minus 4ac plus 16 whole divided by 2a, 2 into 2. So, this comes out to be 3 plus minus 5 by 4. So, it is 2 and minus 2 upon 4, 1 by 2. Sin x cannot be equal to 2. Because minus 1 is less than or equal to sin x 1. And in trigonometry in class 10th, we have read that the value of sin x and cos x oscillates between minus 1 and 1. This aspect we shall take up in graphs. Again in this class. So, therefore, sin of x equal to minus 1 by 2. Now, we have to find the general solution. Sin x, we find the principal value first. Principal value values are 180 plus 30, 210 and 360 minus 30, 330. Principal values lie between 0 and 360. Sin x is negative in third and fourth quadrant, and in third quadrant we have the value as 210. Of course, making use of that chart, that is 180 degree plus theta we take in the third quadrant, 360 minus theta takes in the fourth quadrant. So, here we have sin x equal to sin of 210, and this we convert in radians, because it is convention to write this angle in radians. Sin x 7 pi by 6. So, this is sine of this, because sine of 7 pi by 6 is minus 1 by 2. So, therefore, we use the formula x equal to n pi plus minus 1 raised per n alpha pi by 6. I write down the formula here, sine of x to sine of alpha, then x equal to n pi plus minus 1 raised per n to alpha. So, of course, where n belongs to set of integers, we can take up another example. This is find the general solution This is tan x plus tan of 2x plus tan of 3x equal to tan of x, tan of 2x, tan of 3x. It is a very typical example in trigonometric equations to find the general solution in this case. Transpose tan 3x to the right hand side. So, or we have tan of x, tan of 2x, tan of 3x, tan of x, tan of 2x minus tan 1. If you open the bracket, this will be tan of x, tan of 2x multiplied by tan 3x. And if you take this tan 3x to this side, it is minus tan 3x. So, I can write the result as tan x plus tan of 2x minus common tan 3x into 1 minus tan of x tan of 2x, or tan of x plus tan of 2x divided by 1 minus tan of x tan of 2x minus tan of 3x. So, on left hand side we apply the formula tan of A plus tan of B, 1 minus tan A tan of B, which is tan of A plus B. So, this is, or tan of A is x, B is 2x minus tan of 3x, or tan 3x equal to minus tan of 3x, or by transposition twice tan of 3x equal to 0. That is, you can write down here one more step, tan 3x plus tan of 3x equal to 0, or tan of 3x equal to 0. Here implies sin 3x over cos of 3x equal to 0. Therefore, sin 3x equal to 0. General solution is therefore 3x equals to n pi, x equal to n pi by 3, where of course n belongs to set of integers.